Good morning, everybody. Happy Tuesday. Let's talk about magnets. Here we go. It's Tuesday, March 31st. So our I can statement of the day is I can explain how magnets interact with other magnets to produce motion. So let's review what we talked about yesterday. A magnet is a type of metal that can attract other metal materials. Magnetism, a force that can attract or repel objects that have magnetic material like iron inside of them. And we're going to go into more detail about that today. Something I want to point out is our vocab words we also talked about yesterday was attract, which is to pull closer, and repel, which is to push away. Attract, pull closer, repel, push away. We also started talking about the poles on the magnets. So where the magnetism is the strongest on the magnets, there's a north pole and a south pole. So forces of motion. So magnets cause forces of motion. So a force is an interaction that will change the motion of an object. So if you think about it this way, when a football player is running down the field and they're going straight, and then another football player hits them from the side, they're going to change direction. They're going to go somewhere else. When they get hit, they're going to be forced in a different direction. And motion is the movement of an object in a certain direction. So when that football player is running down the field straight, that's where they're going. It's the movement they're doing. The force is what the other football player puts on them. They hit them and they try to take them down, and that changes their direction. So there's forces and motions that we talked about yesterday: repel and push, when an object moves away from one another, and attract and pull, which is when an object moves towards one another. So these are the forces of motion. So these are the changes in directions due from another object, which is attract and repel. So magnets have these things, they're force fields. So they occur whenever a charge is in motion. So basically what this means, if you look at these pictures, magnets have like these imaginary lines that go around them, and they show the direction in which their magnetism is being put out. So I'm going to go into that a little bit more. So if we look at a south pole and a north pole, here it shows the magnetic lines. And what you can see is that they're going towards each other, right? North and south going towards each other. You see the arrow, it's touching the south. It's actually going to pull them in. It's going to attract those two magnets. So those magnetic force field lines are showing that they're going together. So that means those two sides of the magnets are going to attract. When we have two opposite sides of magnets, so south and north or north and south, the magnets are going to attract. But when we have two of the same, the magnets are going to repel, which means they're going to move apart. And you see that more here with the north and north. You can see the lines are different. Now the force field lines are moving away from each other. They're not connecting because they're the same line, so they can't connect. Where if this was a north and south, as we saw in this picture, they go towards each other, they connect. So this is going to make the two magnets repel. That's the motion they're doing. They're moving away from each other because their magnetic force field lines cannot connect. So putting it all together, when magnets of the same poles are put together, their force field pushes them apart. When magnets of different poles are put together, their force field pulls them together. That's it for today. I'll see you tomorrow.